In this next step, we will create the actual footprints for the parts that we added. In the meantime, I added a couple of different capacitors where we will create footprints too. They're all Murata 0603 components, so they all can have the same footprint, which will be very simple and easy to do. So what's the difference between the schematic and the footprint? Well, the schematic is a representation a symbol for the actual part that you will use, and we will later on use that schematic symbol to create a schematic, functional schematic on a sheet. The footprint itself is its physical instantiation, which will be the part that is actually physically placed on the board and that we will later get manufactured. So in order to create the footprints for the certain different parts, we need to get to the data sheets and figure out what the footprint has to look like. But first, let's add a footprint library. Again, right-clicking on your project, add new to project, PCB library. This will create your PCB library with an empty component inside of it. And again, let's go and save this. We can also right-click on the project and actually save the project if we want to. Now we don't have any open projects at all. These are other libraries. All right. First, let's create the most complicated part, which is our microcontroller, the MSP430. And in order to find out what footprint we use, we have to go and get back to the datasheet. And if we, on the datasheet of this part, if you scroll actually almost all the way down, this information is most of the time at the bottom of your datasheet. We can see that there is information on the packaging. So in this case, we are interested in the plastic small outline, the TSOP package, and they give you an optimal footprint that they recommend for this particular package. It turns out that Altium has a nice way of how to create these more standardized footprints. What we can do is we can go to Tools and use the IPC Compliant Footprint Wizard. What's sometimes a little bit complicated is finding out what package the manufacturer chooses and what the IPC code for this particular case is. So in this case, what we had was a small outline package. So we have this one here with small outline package with J wings and small outline package with gull wings. And back here we can actually see that it can say that this is a TSOP package. Excellent. Let's choose that one. Next part, they will ask for the different ranges and sizes. So in this case, we want to know the width, and I am currently using the data sheet behind it to get all this information. So we have a minimum of 6.4 to 6.6. The maximum height is 1.2. This particular package does not have a thermal pad. We use calculated values, and we want to choose medium density for our package. We choose everything default, and then at the end it will give us a name. We can keep that one too, and in this particular case we really want to add it to our current PCB library, the parts library itself. And here's our part. By hitting 3, we can actually see its 3D model of the part. And by pressing back 2, you get back into your 2D view. And as you can see, as before, we have pin 1 through 10, and then 11 through 20. So next step is important because now we have to go back into our schematic library and associate this particular schematic symbol with the footprint that we just created. And you can do that by clicking here on the bottom on Add Footprint. You can browse for the part library that you want to use, and you can then find the different footprints that you created and associate them to it. What you should see down here is the actual 3D representation of the part that you just created. Next in our list, let's choose the switch, because this is slightly more complicated, because here we actually have to make it by hand. So what we have to do is we go into our parts library, we can right click in here and create a new blank component. And again, if we go and actually find the data sheet for this switch, we find something like this, which is a mechanical representation of the device. So you have mechanical drawings, but most of the time they also give you a mounting pattern. In this case, it's 2 holes that are 0.276 inches apart, and the holes have a 65 to 72 mil drill. So we now need to create this particular pattern in this component. First, let's rename this to 1415-351, which is one of the numbers I just found on the datasheet. The next step is we have to place a pad. So we set a pad. Let's put that one at 0. And we enter in here the different sizes that we just found. And a little trick up here on the left symbol, you can actually click on toggle units and switch it from metric to imperial. So the location is 0, 0. And what we want to do is the hole size should be 72 mil. And the pad size around it should be bigger than the 72 mil. Usually you want to add about 15 mils on both sides. So let's make them 100 on both sides. And the designator is going to be number 1. We can copy this particular part over. Again, I want to switch to imperial metrics, and now the X position should be at 276 mil, and this is now designator number 2. Our part is almost there, so we have the 2 holes, that's great, but we don't know in which direction the actual switch goes. So if you remember looking at the schematic symbol, the switch has 2 holes, 2 pads or pins that come off from it, these 2 pins, and then the switch sits on the side of it. So why don't we actually indicate where that would be by using the outline or overlay mode. And what we can do here now is we can right click, place a line. Oh. And what we can do, or just press PL for place a line. What we can do is we can draw the box of the total outline. So let me set this to 0, and we set Y to 472 mil. Oops. We have to do here the same thing. Wait, let's put this one to 0, 0. 472 mil 0. And this is actually the width of our device. Control C, we copy it, and with space we can actually rotate the device, or the part that we have in our currently selected, and that's the approximate size and location of that switch. All right, we save that. Again, we go back into our parts library, add footprint, browse our library. In this case, we use this particular piece. We can see the footprint, but it doesn't have a nice symbol, 3D symbol. You could place a 3D symbol in here for this switch if you find one, but in this case, we just leave it at that. Next part will be these components, the 0603 components and the LED. Again, for the LED, we go and look at the data sheet, and what we find in the data sheet is physical drawings, and if we scroll down we find information on what the performances are of the LED, but again we actually find the footprint for it. What we could do is draw this again manually, and let's do that for this particular part, and I will show you for the capacitors how I can use the IPC Footprint Wizard to actually make the capacitor parts themselves. So again, we go back into our PCB library, create a new blank component, and again we press P for placing a part, and again we want to place a pad. Let's place this first pad over here, and in this case, instead of having it a multi-layer hole in the middle, what we want to do is we want to create and make this a top layer part only. So this will now become a pad. Doesn't have a hole drill in it. You can see the hole size is gone. In addition to that, we want to make this, instead of round, rectangular as the pad showed, and we want to make it 1.5 millimeters by 1.5 millimeters, or the measurements that we find in the data sheet. Again, we copy this one, I will set this to 0, and the distance from edge to edge should be from center to center should be 3.5 millimeters, and that's our part. Again, set the designator to 2, so one of them has designator 1, the other one has designator 2. If you remember, that's what I used in the LED to mark one pin and the other pin. In addition to that, I'm gonna place a line, so PL, place a line, and mark one of the pads as being pin number 1. We go back into schematic, and we add our PCB component. I forgot to rename it. Back, schematic, add footprint, browse, LED footprint. Excellent. So a few more components. So let's go back into our parts library. In this case again, we do an IPC compliant footprint wizard. And what we want to do is create a chip capacitor. So it's 2 pins. And we enter in here all the different measurements that we need. The body length, bandwidth range, etc., etc. And this will create us our footprint, and we can say that it has a positive pin location, can be pin 1 or 2. That will add a little marker here. In our case, we don't have that. And after that creation, again, it will add the footprint in here, and you go and add it to your parts.